Good evening, students. Pushti sir again today back with a new conceptual question for you. Today's topic on uh, electromagnetic induction topic. Okay, it's an interesting problem. Just look at the situation. I have a very long, hollow, very long. L is very large compared to the radius of this cylinder. It's a long, hollow, non-conducting, rigid, massless cylinder. So many attributes. Carries charge capital Q uniformly on the surface. Its radius is R. Length is L. L is much greater than R. A block of mass M, just see, the string is wound around it, light inextensible string is wound around it, supporting a block of mass M at one end. Is hanging from an inextensible string, that block a mass of mass M, which is that string is wound around the cylinder. The cylinder is supported at both ends by some arrangement. Maybe these ends are closed and some massless rod will be supported by some bearings at the ends. So this cylinder is supported at its ends by frictionless supports. What will be the acceleration of the block? If I release this block, what will be the acceleration of the block? The block will try to pull it down, pull itself down. The gravity will pull down the block. So this will start rotating the cylinder because the string is wound around it. And there cannot be any slipping between the string and the rod, the string and the cylinder surface. Remember this. So this will rotate like this. Okay, fine. So this will come down with some acceleration. I want you to calculate that acceleration, find the value of that acceleration. That's all. The left hand side से इसे दिखेगा हम वो radius r, length is into the plane of this diagram, plane of this our board, and the string hanging supporting this block A. Gravity force acting on the block, tension on the string will be acting upward, and this tension at this end will start acting downward. That's it. And this will be rotating with angular velocity, angular acceleration alpha, and also angular velocity omega. Fine. Okay. So let's analyze this. The rotating charge cylinder acts as a current carrying conductor. Why it is a current carrying, not conductor, I'll say. I'll better say the better word. Current carrying what? Tell me now, all of you. Solenoid. Why it is so? As you all know, very long current carrying conductor produces a uniform magnetic field inside the कंडक्टर नहीं भाई, हम उसको बार बार कंडक्टर क्यों लिखते हैं? कैरिंग सोलेनॉइड, करंट कैरिंग सोलेनॉइड produces a uniform magnetic field inside its volume, neglecting the end effects. This magnetic field is given by B is equal to mu naught Ni. N is what? Number of turns per unit length of the solenoid. I is the current flowing through the turns. Okay? And B will be along the axis only. All of you know this for a cylinder. But how it is a solenoid? How this rotating cylinder will act as a solenoid? The charge is fixed and distributed uniformly over the surface. So charges also will be rotating. Yes or no? So this mu naught Ni, which I wrote, where N is number of turns per unit length and I is the current flow through each turn. So N into I will be current per unit length of the solenoid, because I is current in each turn. If I write is current through each turn, I write current through each turn, I. So then Ni is the current per unit length of the solenoid, because N is the turns per unit length. Fine. So therefore B I can write as mu naught into current per unit length of the solenoid. This is a more fundamental expression. Okay. So in the given problem, charge is revolving around the axis. We know that a revolving charge small q forms an equivalent current loop given by I is equal to q into frequency of revolution. If angular velocity is omega, then frequency omega by 2 pi. Okay, q omega by 2 pi is the equivalent current in that current loop, which is formed by a revolving charge of charge small q. Okay, so the current per unit length of this solenoid will be how much, of that cylinder will be how much? Charge per unit length into omega by 2 pi. Yes or no? So that is q by L, charge per unit length, into omega by 2 pi. Q omega by 2 pi L is the current per unit length along that solenoid, because the cylinder will act as a solenoid. Because current will be, charges will be revolving like this, will be revolving like this. I am showing you the diagram. This is, they will be revolving like this. They will be revolving like this. So that means current will be flowing like this then. So is a current flow is like a solenoid. Okay. Now I think you have all understood the situation. This revolving cylinder about one axis now behaving like a solenoid, ideal solenoid, a very large length. So what is the current per unit length? Charge per unit length into omega by 2 pi. Charge is capital Q by length, omega by 2 pi. Q omega by 2 pi L is the current I, current per unit length. So what is the B then? As per the B is, as I told you, mu naught times the current per unit length of the solenoid, that is mu naught times q omega by 2 pi. That's it. This is the cylinder is accelerating due to the hanging block. Omega also will be increasing, so B also will increase. I divert a bit to the electromagnetic induction situation. You know, if we have a uniform magnetic field in a cylindrical region, this is cylindrical region, the length is into the plane, and B is uniform and changing with time at a rate of dB by dt. Then what happens? A non-conducting electric field appears, which is known as ENC, I am writing here, appears in a circular loop, in circular loops around about the axis of the cylindrical region. Yes, sir. Circulating ENC will appear in non-conservative electric field. Any electric field which is not produced by static charges are non-conservative in nature. So this is not even produced by charges, it is produced by varying magnetic field. So it is a non-conservative electric field closed loop. And since it is a cylindrical region magnetic field, so from symmetry we can prove that the closed loops are circular closed loops. Okay, so creating circular loops around the axis of the cylindrical region. Obey in which direction? As per the Lenz's law. If you point your right hand thumb in the increasing direction of the B, then whichever direction your other four fingers will curl around, opposite to that ENC will appear, because minus d flux by dt. Minus means opposite to that direction. So again I am saying, repeating, if you point your right hand thumb in the direction of increase of flux, then the four fingers curl round in a direction whose opposite is the ENC direction. Okay. So if I point my right hand thumb into the direction of increase of B, then clockwise direction my other four fingers are curling around. So anti-clockwise direction will be the ENC induction. ENC will indicate anti-clockwise direction. That's what I've shown in the diagram in red color. And that value is already you must have studied in induction chapter, R by 2 radius, that is R by 2 divided. R is the distance from the axis and R less than capital R. Capital R is the region of the radius of the cylindrical region. Radius is R is the radius of the cylindrical region in which B is existing and changing. Okay, this you know. So this I am going to use for our situation. So coming when R greater than R outside region also it will appear, but we are not concerned with this with it in this problem. Okay, that's what I am saying you. That's it. So coming to our problem, we will see. This is situation again I am redrawing. So what it is, that same cylindrical cylinder, and this is hanging block. I'm showing it by an isolated circle, and this is ENC. As I told, on the surface it will be anti-clockwise direction like this, because this is increasing into the plane. So omega and alpha direction are shown. I'm looking from the left hand. Charge is Q. So what is ENC? Capital R by 2 dV by dt at the surface. Then dV by dt how much? What is the B? B you already know. I'm giving mu naught Q omega by 2 pi L. उसका डेरिवेटिव mu naught Q omega by 2 pi L dV by dt of B. So उसमें mu naught Q by 2 pi L को बाहर ले आऊंगा. So mu naught Q by 4 pi L d omega by dt. d omega by dt जो alpha angular acceleration. As you see, ENC is in anti-clockwise manner as omega is increasing, leading to the increase of B into the plane. That's what as per the Lenz's law I told you, already explained you just now. Okay. So now I'll explain the torque then. If this is the ENC, then into Q will be the force tangential direction, into radius will be the torque. That's what I multiplied Q and R to the ENC. So torque electrical in anti-clockwise manner is mu naught QR, just multiply QR to this, mu naught Q square R square alpha by 4 pi L. That's what I wrote. And this is, you know, this has no inertia, no moment of inertia. So net torque has to be 0. Are you all clear? If net torque is not 0, then it will have infinite angular acceleration, which is not acceptable physically. So torque electrical anti-clockwise must be balanced by torque mechanical clockwise. But what is the mechanical torque? That M is mechanical torque. That is tension into R. This is tension into this, the momentum R, so TR. So TR clockwise will be balancing mu naught Q square R square alpha by 4 pi L will be balanced by TR. TR clockwise, this is anti-clockwise. So one R you remove and T becomes mu naught Q square alpha, 1 R is over, so only 1 R by 4 pi L. This is equation, value of T. Now come to the hanging block. mg है minus T. mg minus T is mass into acceleration. That's it. Newton's law. So mg minus T is ma. T already I have found out equation 7. So bring it to one side with it A. Alpha R must be A because there are no slipping between the string and the surface of the cylinder. So alpha is equal A must be alpha R. So अल्फा की जगह ए लिख देता हूं और राइट को ले आता हूं. सो ए कॉमन ले लूंगा. तो m प्लस म्यू नॉट क्यू स्क्वायर बाय 4 पाई एल इज mg. सो ए निकल गया आपका आराम से. तो m डिवाइड कर दूंगा तो g डिवाइडेड बाय 1 प्लस म्यू नॉट क्यू स्क्वायर बाय 4 पाई ml. वेरी सिंपल क्वेश्चन, वेरी सिंपल आंसर है ना. So ये एक क्वेश्चन है, इसमें बहुत सारे चीज आपको मैं कंबाइन कर दिया, इलेक्ट्रोमैग्नेटिक इंडक्शन, देन नॉर्मल न्यूटन्स लॉ एप्लीकेशन, टॉर्क concept, a small easy rotational part, okay, and this rotating cylinder acting as a solenoid. So these things these concepts we have discussed in a single problem like this. I think it's a useful problem. All of you must be, some of you might have done it. Those who have not done it, just now you have understood this, so you are at par with others who have already done it. Don't do it. So all the best. I'll soon meet with some very conceptual thing, and all the best for your upcoming examinations. Thank you all. We'll meet soon.